Okay. Okay. So, hi everybody, and welcome to XFC 2025. This is the fifth iteration of the Explainable Fuzzy Challenge, and sorry about that. The fifth iteration of the Explainable Fuzzy Challenge, um, where we have uh, student teams make Python-based agents for uh, controlling agents in Kessler, the Python video game. Kessler is an open source game. We created it in part for this competition, but also as a general simulation environment to be used for reinforcement learning type problems. So the agenda for today, we're going to go through these intro slides. Unfortunately, our sponsor couldn't join today, Nick Ernest from Tallis, but we'll have a few slides detailing what XFC is about and what we're going to do. We have student presentations. We had a time limit of 8 minutes each. I've only received one of the student presentation videos, which is okay. If the others are on and want to present live, we can do that as well. Then we'll get into the competition live stream. So this will be on YouTube, not in Teams. So the link was in the meeting invite, and we will start the live stream when we get to the actual playoff portion of the competition today. And the student agents will be evaluated live. So they will be evaluated live in Kessler against each other in a playoff format. And since it's adversarial, the agents will be competing directly. We'll then go through some results, at least for the playoff itself, and then closing remarks. I will let everybody know that the live stream and the recording of this will be put up on the YouTube channel. And the student presentations I can put up separately if the teams agree to it, but we'll talk about that afterwards. So a quick introduction for XFC. XFC is a competition using fuzzy logic and machine learning methods to play a video game. This is the game I already mentioned, Kessler. It's a Python arcade game based on the classic arcade game Asteroids. And one focus of this competition is that the agents need to explain their actions. So they have to have some sort of explanation capability to explain why they're performing, a particular action at a particular time. We also have seminars that we do throughout, usually the fall semester. This year, we reduced the scope of the seminars that we were giving, partly because there were a lot of ones that we had already given on that were already on our YouTube channel, and we didn't want to be redundant. And also because we're sort of going through a reformat of the competition. So this year, we didn't add any new uh, seminars on a lot of the topics that we've done in the past. We are developing more seminars for more direct, I'll say, help for students to be able to get up and running with Kessler and doing things like reinforcement learning within it. Some of the example code was already put on the repo, like fuzzy-based controllers in Kessler with skfuzzy. We also have an example to optimize those with genetic algorithms. That's not already pushed, but that will be, and we'll have that in there for future years. We started off this year with 31 students on 10 teams, which is close to the max we've ever had, although only 4 teams submitted agents for competition. That's fairly typical. That's one thing we've been focusing on is how to increase the number of teams that we retain throughout the year. What are the goals of XFC? In the shortest term, we want to foster student development of student skills relating to Python and object-oriented programming and software development, repository management, machine learning, including reinforcement learning, gradient-free optimization, and gradient-based optimization if they desire. We've had seminars given on that by Dr. Barnabas Bede. Application of fuzzy systems towards interesting and relevant problems. Fuzzy isn't taught very often, and when it is, a lot of times it's focused on different types of problems, I'll say, that may not be nearly as engaging as a reinforcement learning type problem, like a Python arcade game. Explainability of fuzzy-based AI systems, project management and teamwork, and presenting to audiences. You know, all those soft and hard skills that we want students to develop. And over the longer term, one of the reasons, the reasons that we do this are to disseminate those skills into the workforce and research areas, and also improve XAI and fuzzy adoption and understanding and implementation. So, it's a win-win. We help foster student development with this competition by doing something fun, and also, we have more talented students come out of it as a result. So everybody wins. A little bit of history on XFC. In 2021, this was our first competition. We did this based on the Fuzzy Asteroids Python game. This was a version of the Python arcade game called Asteroid Smasher that we had modified. And we had 3 student teams compete. They only had 1 semester, and we had some really good solutions. They had really good solutions based on the short time frame. XFC 2022, the second competition, we extended this to be multi-vehicle, and agents had to control both single and multi-ship scenarios. In this case, we had, again, about a dozen teams signed up, and only 2 submitted final agents for the competition. And this is when we transitioned to the entire year. So we had multiple seminars starting this year throughout the fall, and then the spring was mainly development for Kessler. Or well, at this point, it wasn't Kessler, it was still Fuzzy Asteroids. XFC 2023, we switched from Fuzzy Asteroids to Kessler. This was basically made from the ground up to be much more user-friendly and more efficient for reinforcement learning. We developed this at Talus, the company I work for. It is open source, so we welcome contributions. And in fact, we've had several competitors, especially last year, contribute to Kessler and find both bugs and ways to improve it so it's more efficient. So please, if you are interested, go take a look at the code base. It's on GitHub at that address. And you can also pip install it directly on PyPy with pip install Kessler game. So in 2023, again, we had 3 teams submit final agents, seminars similar to 22. Last year was the 4th competition, and the biggest change was we added mines. So previously in Kessler and Fuzzy Asteroids, like in the classic Asteroids game, you would just shoot bullets to hit asteroids. The asteroids would split into smaller pieces and blah, blah, blah. Last year we added mines to add a new dimension to the game, and these detonate with a certain blast radius and blast force, and they are timed, so you can drop a mine, and after a certain amount of time it will detonate and hit, quote unquote, everything in that blast radius. This is the only thing outside of crashing your ship into another, or ship collisions, the only way to have any sort of, I'll say, offensive capability in Kessler, because you can't shoot the other ship. We are not wanting to go to that directly, at least for the time being, so mines added an interesting dimension. It made the game a lot more complex, especially on the strategy side. We also added custom ship sprites for each team with peer-voted winners for best sprites. This is a lot of fun. We'll see the custom sprites again for this year, but last year was the first time that we did that. This year, we don't have too many changes in the game. We're going through a bit of a transition period for the competition where we are revamping both the seminars and the overall flow along with what we want to add to the game. We're also balancing this with an additional competition that we're holding at Fuzz IEEE this year. Last year we had an additional competition after XFC at Wiki, the World Congress for Computational Intelligence, which is an IEEE conference. This year we're doing Fuzz IEEE, which is the Fuzzy IEEE conference. So we're going through a bit of a transition as we revamp a lot of the things. The recordings are all on our YouTube channel, both from previous competitions and the seminars. So there's a lot of seminars and highlight videos, all of that. I highly recommend going to watch some of them because they're pretty interesting to see what students came up with in the past. And you can see the evolution of both the competition and the game as it evolved over the years. So the organizers, myself, Dr. Timothy Arnett, I'm a senior AI researcher at Thales and the lead organizer of the competition. Zach Phillips, he's in the office with me at Thales. He was the primary developer for Kessler. It was developed, let's see, when was that? That was in fall of 23. We've made some incremental changes and we've talked about making some big improvements, but he was the main developer originally. Lynn Pickering, she's a PhD student at the University of Cincinnati who's actually defending her dissertation tomorrow. So uh, Lynn is wrapping up her PhD work and yeah, has contributed a lot, especially in the early years to XFC. And Sam King, he's an automation engineer at Intramotive. He's been helping out with the competition for a few years. He does a lot of things like the website. So he was the primary developer of the website and helps out with a lot of the other tasks. Judges. So part of the competition, we have judges that judge the explainability and the innovation of the student solutions. And this year it will be Sam King, Zach Phillips, and Dr. Nick Ernest. Um, Nick Ernest is also in my office at Thales and is also the primary sponsor of XFC. Explainability. So this is a big part of the competition. So what are we going to do? AI solutions are judged on their explainability. This is done by judges assessing the quality and presentation of explanations from the AI. They're scored based on criteria such as ease of understanding, quality of explanation, sensibility of actions, etc. And the solutions, the agents created by the students, will be run through dedicated scenarios to elicit explainable behaviors. Essentially, we want to put them in situations where we would want to understand which action they took and why. So we have scenarios that are dedicated to that. This might be something like, we have two asteroids and we want to know why it selects one instead of the other. Some things like that. It gets a little bit more complex. I already talked quite a bit about Kessler, but some more detail going into it. Again, this is a Python arcade game that's open source. Please use it. And if you find anything or want to suggest improvements, please do. And it's a 3-DOF simulation, so it's yes, it's sorry, 3-DOF simulation, and it wraps out the edges, meaning that the asteroids and ships, if they exit the area on at one edge, they will wrap around to the other side. The only thing that doesn't wrap is the projectiles or weapons, I guess I'll say, the bullets and the mines that the ships can drop. And one thing to note is that asteroids hit with projectiles break into smaller pieces. They break into 3 smaller pieces, and any piece contacting the vehicle destroys the vehicle. And in this context, what that means is that it takes a life. You'll see that the ships have lives in the game. Typically, they have a very small number of lives, so essentially the ships can be hit a small number of times before they're done for that scenario. It is adversarial, so multiple ships are controlled by different control systems. And ships can only shoot asteroids, not other ships, with bullets. Ships can also collide, and mines hit everything that is in their blast radius when they detonate, including the ship that dropped them. So you can be hit by your own mine. We have a couple different graphics options. I won't spend too much time on this, but we have a relatively basic tkinter based graphics, which is the default, which is also what we're going to be using today just because it's a bit easier. We did develop some UE5 based graphics, which do look pretty fun, but it's a bit arduous to get going and run. And it doesn't have a lot of the functionality built in yet that we have in tkinter. But we hope to add this in the future. It's just been put on the back burner for now. The scenarios that we're going to see today, there are several that will look pretty familiar to those of you that have been involved in past XFCs. We do have some different ones, but agents are evaluated over a whole bunch of scenarios, and we don't tell the competitors what they're going to see beforehand. So we want them to train their agents as best they can, get good coverage in their training set, but then we're going to give them new scenarios that they haven't seen before. The difficulty and number of asteroids varies wildly, and the scenarios are changed each year. We do change them a little bit, just so we're not getting agents that are overfit, we'll say. Explainability, I already mentioned this, but yeah, we have these dedicated scenarios that are made to elicit certain explanations to figure out what the agents are doing. Okay, so let's talk more about this year. We have four competing teams. We have Team Floppy Disk from the University of Alberta with Jamie Yakimetz. We have Team Hit or Miss, also from the University of Alberta with Akila, I hope I don't butcher this, but Akila Edirasinge. Hopefully that's not too bad. Team Swedish Vikings from KTH Royal Institute of Technology in Sweden with Edvin Jiang, sorry, and Simon Stoll. And then we have Team Temp Variable, which, great name, from the University of Cincinnati here in the US. And we have Garrison Weddingle, Randy Hucker, and Gianni Gaetano. So, like I mentioned before, we have custom sprites. We started doing this, and the teams all submitted a custom sprite this year. So these are their sprites, and we actually do a peer award for this, where the teams actually vote on the sprites that they like the most, and we do a ranked choice voting, so we get a first, second, and third place for best team sprite. So these are the ones we have this year. We have Team Floppy Disk on the left, Hit or Miss with the Turtle Fortress, Team Swedish Vikings, and then Team Temp Variable with their own little modified F-22, a space F-22, I imagine. So a lot of fun. We've had some really interesting ones last year and some interesting ones again this year, but yeah. The scoring for the competition, it's based on the number of asteroids hit during all the scenarios evaluated. If there are ties in the asteroids hit, tie breaks include accuracy and then total deaths. Playoff seeding was determined by a scoring of agents against a baseline agent. That this baseline agent was created by us, the organizers. It doesn't really matter how performant it is, except for it does do certain things that put the student agents in situations where they can't just act as if they don't exist. They will do better if they account for the other agent. Since we have four teams, it's a relatively straightforward single elimination playoff bracket. Round one is seed 1 versus seed 4, and seed 2 versus seed 3. And then the final round is the round 1 winners for first and second place. And then we have an additional match between the other two for third place. And based on the results from evaluating all of the agents submitted against that baseline agent, our team seeds are: the first seed is Team Floppy Disk, second seed is Team Hit or Miss, third seed between Swedish Vikings, and fourth seed Temp Variable. Prizes. So our prize pool has been variable over the years, and it's been somewhat hard to secure, but we were able to secure funding again this year for prizes, and the total pool was back up to $3,000. We have $2,250 pool for the actual winners of the playoff competition itself. So this is only based on who wins the playoff. And for first place we have 1,100, second 750, third 400. We also have prizes for explainability. The top scoring teams, as judged by the judge panel, will receive prizes, first, second, and third. This will be the same ranked choice voting that we have for, not the same, but sorry, it will be based on ranked choice voting from the judges. And so we have 125 for first, 75 second, and 50 for third. We also have most innovative, a prize for that, and again scored by the judges, and again the same split for first, second, and third. And the custom ship sprite peer award, I already mentioned this. This is voted on by the student teams, again first, second, and third, same split. What we need the teams to do, though, I think we have most of them on the call, or they'll see this afterwards. But and I'll send out a reminder. But we need the teams to submit their votes, and I need them to vote in order first, second, and third. We do have the ship sprites up on the website. I'll just go ahead and pull that up right now. But if you go to our website, this is the address for the website. And then if you go to the ship sprites page, we have all of them. So you can see all of the ship sprites and the team names. And so I just need a vote 1 through 3 from everybody. And of course, you can't vote for your own team. Okay, so I think there was originally a different date for results, just due to timeline and my own personal schedule. We will be getting results out for everybody for explainability and innovation by June 13th at 5 p.m. Eastern. And the organizers will contact teams for prize disbursement details, but we'll be in contact by then. I do want to highlight that we normally present XFC at NAFIPS and IFSFA, or sorry, at NAFIPS, but NAFIPS is doing a joint conference with IFSFA this year in Banff, Canada. So a nice location to visit. This is the website. I don't know if we'll have a special session this year on XFC. That is still tentative, but at the very least, we will have discussions on XFC. A lot of people in the NAFIPS community are involved with XFC, including giving the seminars, and a lot of their students compete in XFC. So that will likely happen again. At the very least, there will be discussions on XFC with a lot of the conference organizers. But we may have a special session where we discuss the competition, the results, what is contributing to the community, and potential changes, improvements, that sort of thing. And we also highlight student solutions. And in fact, there have been a lot of student papers that have been put into not only NAFIPS, but other conferences. And there's been a master's thesis that used a lot of the things that they had developed during XFC for part of their master's thesis. So it's not just a little competition. It also offers you a good way to create material that is great for publication. In addition, like I mentioned, the IEEE Fuzzy conference, this year it's in Reims, France. This is the conference website. We also have a page on our website dedicated to it. You can't, if you're competing in XFC, you can compete in this one as well. It's just an additional competition. The timeline is on the website. We won't be having agent submission until the end of June. So if you'd like to take time after XFC, especially after seeing the results, you can modify and make changes to your agent up until that submission date. This one is just pure competition. We're not going to be judging explanations at the moment. We've talked about doing this in the future, but at the moment we're not doing that. And there's no other seminars or anything. This is just a pure competition to get the best results. Again, all students are welcome. Please go register if you haven't already. If you're already in XFC, or if you're watching and you're not already a part of XFC, please do. The session itself, it might be hybrid with a live stream at the conference. Last year at Wiki, we weren't able to do this, but the worst case is it gets recorded just like this and then uploaded afterwards. But we're working with the conference organizers. We'll see what we can do. It really depends on the setup in the room. And I'd like to highlight some special thanks, especially to Dr. Barnes Bede and Dr. Scott Dick. They have dedicated a lot of time. They've donated their time to give seminars in the past. We've had a lot of seminars on optimization and fuzzy systems, explainable AI and fuzzy systems. And they also use Kessler for some of their in-class development and projects. Also want to highlight one of the competitors last year, Jai Fan from the University of Alberta. He found a lot of bugs and made a lot of improvements to Kessler to make it a lot more efficient. We've already talked about making Kessler a lot more efficient in the future. That's still to be determined what we're going to do. But in the meantime, again, if anybody here is having a lot of fun with working in Kessler and wants to make changes, please do. It's open source. Go take a look. And yeah, we'll do some pull requests. Also want to thank Nick Ernest from Talos for sponsoring and promoting XFC since its inception, Zach Phillips from Talos for helping author Kessler, and Kelly Cohen from the University of Cincinnati. Besides being, a heavyweight in the fuzzy community, he's promoted XFC since its beginning and has gotten a lot of teams and a lot of students to join and make solutions. So thanks to all of them. Okay, let's get to the fun part. So this is our playoff bracket. Before we get to the playoff, we will have student presentations shortly, but I'm just going to highlight based on the seeding that we have. This is what our bracket looks like. So we'll in the first round have team floppy disk versus team temp variable. The winner of that will advance to play the winner of team hit or miss versus team Swedish Vikings. The winner of that will get first. The runner-up gets second. Loser of that one gets second. And then the losers in the first round will play for the third place prize. So with that, first I'm going to ask if any of the teams that are on the call are presenting, and if so, I'll let them go first to share their presentations before I get to the recorded presentation that I already have from Team Hit or Miss. If you can put in the chat or raise your hand if you had planned on presenting. If not, that's okay. We will play Akila's presentation and yeah. Okay, Jamie. Let's see. Jamie, if you can unmute, I think you have the ability to unmute.
Okay, how's this?
Yep, I can hear you.
Okay, awesome.
So you should be able to share your screen.
Okay, I will work on that.
I'll stop sharing.
Okay, we should be live, or it's working on it.
Okay, yep, we can see your screen.
Okay, perfect. Thanks, Tim. So yeah, this is my XFC, and as Wayne Gretzky once said, you miss 100% of the asteroids that you don't shoot, which is why you should always be shooting as many asteroids as you can. And it's my first year in the competition, but I thought I would look into the previous years to see what previous participants have done, and I thought it'd be fun to put together. Sorry, just yeah. So of course I want to thank Tim for putting all of this together. Looks like a lot of hard work, which is awesome. Got to thank Jai Fan as well to telling me about this and introducing something you'll see later, which is the nickname Ganook mode. Thanks to our friend Aiden who thought of the name and texted us at like 2 in the morning to suggest it, which I guess is when the best ideas strike. And I thought I'd put together a little inspiration board of previous years, some teams that have participated over the years. Of course, there's OMU, there's our good old hit or miss, Neo, Baja Blast, and of course many others that have participated in the past. So shout outs to them. For me, my asteroid prioritization was for my ship to shoot the most imminent asteroid that was potentially going to collide with the ship. And if there was not an immediate threat that was going to hit the ship, determine the least amount of turning required to hit any given asteroid. And ideally, of course, do not get hit. All right. So in terms of the aiming logic, it did a lot of linear algebra to solve some quadratic equations to ensure that the interception point is indeed on screen and achievable. Initially, I was aiming at interception points that were off screen, which was not ideal, as you can imagine. And so bottom here, the guide to profit is to shoot the best asteroid, whichever one is either about to hit your ship or is closest to your ship, or requires the least amount of turning, one or the other. My goal was to make a very simple but deadly ship. I figured less was more, and my ship, with the exception of ramming, something else you'll see in a couple minutes here, it just generally doesn't move a whole lot. Moving was a little tricky to get done correctly here. So to save fuel and protect the environment, it doesn't move a whole lot. Sort of a yin and yang of priorities, a bit of a trade-off of optimizing some other stuff in exchange for movement. And then, of course, there's Canuck mode, which, again, we'll get to shortly here. The general strategy with ramming and shooting asteroids, whether or not a life of my own ship is worth a life of my opponent's. And if your opponent is dead, you don't need to split the asteroids and hence the points with them. So you can have them all to yourself, and you can just assert dominance over the asteroids because you don't have an opponent. So why not try and take them out if you can? Definitely learning some lessons throughout this. Sometimes you run something past ChatGPT and it comes back with some crazy stuff you didn't expect it to do. So definitely, if you're using bots, proofread your code and learn some stuff from the other team's agents whenever possible. So to go into a little bit more about the fuzzy side of things, the movement and thrust controller contains multiple fuzzy sets of movement instructions. And if I am respawning and have more lives than my opponent, I would try and ram the other ship. Initially, I was overshooting quite a bit, and it would just fly right past my opponent. So fuzzy logic came in very handy there. In terms of Canuck mode, this was an entertaining last-minute addition, using linear algebra to calculate the presence of surrounding asteroids. It determines, by looking a few frames into the future, if there will be a closing ring of asteroids around the ship. And if it's true, we reserve our mines for the closing ring and space them out a little bit to ensure maximum damage, which hopefully we will see in the playoffs very soon. These are some of my training parameters that I worked on. It was hard to find the exact timing, so I looked at different fudge factors here and tried to figure out what the ideal timing of mine dropping to sort of decimate this closing ring would be. And yeah, it definitely took some experimentation to find like the best timing, but eventually it did sort of come together. Some things that I worked on that didn't get fully implemented were to drop mines just before taking damage to avoid the wombo combo of losing 2 lives at once. So sometimes you've got like a asteroid coming at you and you run out of bullets, so you drop a mine, and ideally you repel the asteroids. Didn't quite work out as hoped, but that's okay. And movement, of course, never really found that quite tricky to get that just correct, so I ended up scrapping it, and I tried to avoid wasting mines by just dumping them at the end of the game, although again, it wasn't quite sure how to handle that, so that never fully came together. Okay, and thank you very much. That's my presentation. Hopefully the playoffs go well for everybody.
Thanks a lot, Jamie.
Yeah.
I do have a quick question, but does anybody else have questions for Jamie? So your I'm gonna mispronounce it. The Ganuk mod.
Yep,
Is
yep.
that only for closing rings, or is it based on like a density of asteroids?
Yeah, it does check for density of asteroids, but primarily it was tested on the closing ring scenario, so that's probably where we'll see it happen.
Okay. Closing ring is, a favorite of XFC to see what agents will do. The mines have sort of made it such that the rings are going to be modified a lot in the future. But yeah, should be fun. And my follow-up question is, right now you say you're using linear algebra for, you're aiming for solving essentially, because it is solvable at the moment. It is deterministic. What would you do in the future if you had, say, sensor noise, or if you
Yeah,
didn't know
that's
exact positioning?
yeah, that's a fine question. Definitely, I would try and filter out the noise as much as possible, and hopefully be able to get a clean result from there.
Yeah, we've talked a lot in the past about adding that to Kessler. Um, we haven't for a number of reasons, primarily because Kessler would need to become more efficient to implement some of the methods that we want to do. But that is a recurring theme that keeps coming up is, adding noise to the game. So this year, we still have the same deterministic behavior, but in the future, we'll likely be doing that. But thanks a lot,
Yeah,
Jamie.
yeah, no problem. Sounds like an interesting twist.
Yeah. Okay. We also have Swedish Vikings on. Swedish Vikings, were you going to present, or did you were you not going to present?
We don't have a PowerPoint presentation, but I can quickly talk about what we did, if that's okay.
Yeah, that'd be great. Please.
Oh, okay, nice. So we used a fuzzy system as like a controller of several submodules, so that we have several parameters that are inputted into the fuzzy interference system, and then that the fuzzy system outputs a kind of danger score switching between these submodules. And these submodules will be a firing module. So it simply tries to score by shooting asteroids and leading asteroids using those linear algebra equations that Jamie talked about earlier. We have similar one to that. And then we also have two movement modules. We have one that is more broad. It's a more of a positioning module that uses a heat map created from the asteroid field and follows a gradient. And then we have another more like a emergency module, which uses randomized short simulations and tries to simply simulate a way in which it doesn't die, because it is usually activated in a situation where there's a lot of danger, lots of asteroids, and it simply tries to find a solution in which the ship gets to safety by randomized simulations. And so we have those three modules and the fuzzy system that switches between these. And then we have the heat map that was used for the positioning module is also used in the explainability segment also. So maybe that will be shown later. But that's pretty much our controller.
That's great. Um, yeah, that sounds very similar to some of the complex fuzzy. Well, I'll say full fuzzy. It's not full end to end or anything, but fuzzy solutions in XFC. The heat map idea in particular has been one that's been floating around that several teams have asked about or have implemented. So yeah, I'm excited to see how it goes. Um,
Absolutely.
yeah, yeah. Thank you.
Thank you.
Does anybody else have any questions for Swedish Vikings? It looks like Jai has a question.
Hi, can you hear me?
Yep.
Great. Hello, everybody. Yeah, hi, Simon. Yeah,
Yeah,
really
hello.
interesting strategies. So what you mentioned with the avoidance by doing like randomized simulations of
Yeah.
maneuvers, that sounds really computationally expensive. So my question is, like approximately what's the algorithmic runtime of that? And then how did you run into any speed performance issues? How many iterations are you simulating? I'm really curious.
So yeah, totally. Computational limitations was kind of the biggest issue, because if you have infinite computational time, you can simulate infinite many possibilities. But what we did is that we kind of created a more bare bones version of the game that only has asteroids. That only has like the asteroid movement part built in, so it runs a bit faster. And then we found that we can simulate about 50. We have 50 maneuvers that we simulate per frame, I believe. And then we kind of we postpone um, the acting upon the simulations until maybe 2 or 3 frames later. So we have 3 frames worth of simulations that we can simply apply. And so we have maybe like 100 different possibilities for the when the ship actually decides what action to use. And does that answer your question?
Yeah, no, that's a really cool strategy. Are you does the ship start from a starting like a stationary position and then finish the maneuver stationary again, or is this like continuous where the ship is just constantly floating around and you're constantly simulating from the current time?
So it really depends what it did previously, if it stands still or not. It most likely it will be standing still, I think. Because it does the action and then stands still and then does the next action if the emergency module or like the simulation thingy is the only thing that it does. It can switch between these quite frequently. So oftentimes it's that it shoots for like maybe 5 frames and then use the broad positioning and then emergency. And so it doesn't really look as uniform unless there's like chaos around it. And then it only uses the emergency module, and then it will stand still and then do its action, and stand still and then do its action.
Wow, yeah, very cool. I don't know if you're publishing your code, but I'd be super curious to learn more about that. Yeah, great. Thank you.
Yeah, totally. We have our GitHub repo. I'm sure we can put out a link to it if you want to look at it. But
I would
maybe it's
absolutely
not
love
the
that.
most good-looking code, but
No, no, mine last year was also really not the best code, but yeah, no, I'd be super interested in that if you're willing. Yeah, thank you so much.
yeah. Thanks for the great questions.
Yeah, thanks a lot, Jai. Thanks, Simon. Yeah, one thing that's been in the works for Kessler for a little bit that we haven't implemented yet, and not to give anything away, but simulating the entire game does tend to slow the frame rate, I'll say. And since Kessler is still synced with the controllers at the moment, it will wait on the controller actions. In the future, we are going to be moving back to how Fuzzy Asteroids was, which was more async, where the game will only wait for a certain amount of time for the controller actions before moving on. So that will be in the future of Kessler as well. Again, we're still in a transition period with the entire competition, basically. So, but yeah, thanks again, Simon. Our last presentation, I don't believe we have anybody from Team Temp Variable. Jai said I have a NASA PC, so it's fine. I do have quite a beefy PC with a beefy CPU. It's maybe not quite maybe not quite infinite compute, but it's decent, I'll say. So our last presentation, since we don't have a team temp variable, I will share again, and we will see Akila's presentation if I can get things loaded. Okay. Um, one thing I'm not sure is if the audio will get piped through.
Hello, my name is Akila and this is
Is the audio not piping through? Okay, let me do that real quick. Okay, we should have audio now.
Hello, my name is Akila and this is hit or miss, cause what else can it do? In the middle of my is my ship sprite, and yeah, what do you mean it doesn't move? Well, most agents try to dodge. Mine stands its ground. I built a fortress-style AI, a controller designed to hold its position and destroy incoming threats. While others move to survive, mine survives by prioritizing precise aim, rapid target selection, and efficient asteroid elimination. No movement means faster decision making and more consistent accuracy. It isn't a shortcut. It is a strategy. Rather than spending extra resources and increasing more variabilities by adding movement, why not allocate all of it to create a perfect or near perfect aimbot with high accuracy? Logic is more asteroids destroyed, higher survivability. And so how are we creating this aimbot? Well, we use fuzzy logic and we give it three inputs. We got asteroid size, meaning it is an indicator of how dangerous it is if it hits. We have impact time, which is an indicator of how soon will it hit me. And we also have turn time, which is an indicator of can I realistically turn and shoot it in time. And so in this slide, you guys can pause it for yourselves and read it. But to give a quick summary, turn time, basically I get the bullet time and get the future asteroid's position to calculate the angle and then how many frames it takes to turn. And if you have
I'm gonna pause here so we can read it real quick. No, Simon, I paused it. Sorry, I was muted. Sorry, Simon, I paused it so we could read real quick. I'm resuming in about 5 seconds.
impact time, which is us using a collision detection formula, basically a bunch of circle stuff and doing math on it. And we look for few conditions where if the circles are touching, it's negative and positive infinite, meaning it is in collision. If circles aren't touching, it's none, meaning there is no collision. If circles will collide at some point, then we have the start time and end time. By circles, I mean the asteroid and the ship. Moving on. So this is a dynamic map, meaning priorities for asteroids will be changing. And so the ship will get stuck turning left and right without deciding on something. And this is called analysis paralysis. It is just like me deciding on ice cream flavors. And so we use something called, well, how do we increase decisiveness? Well, we use something called sticky targeting with movement, blah blah blah. It's a long word, long thing. But basically, the idea is check if the asteroid is in nearly the same position as the one previously targeted. And so basically, this helps us prevent rapid switches by recognizing the fact that the slightly moved asteroid are still the same one. And so we expand on this idea by using a priority retention for previously tracked targets. So basically we carry over all priority of the previous target if it is still valid and assign it to The same one, but new. The idea is to reduce noise from priority recalculations. Minimum priority change threshold. Idea is to stick with the current target unless a new one with significant higher priority is found. This helps avoid flip-flopping between targets due to tiny differences in score. Firing cooldown. Sometimes all of that still isn't enough. And so what do? We use extremely simple logic, meaning if there is no target found, keep firing. And next one is rounding, meaning we round stuff to 1 or 2 decimal places so that it helps reduce sensitivity to minor fluctuations, especially when we got long decimals. And then we got optimizing shooting. How do we do this? Well, we delay shooting until aligned. So we wait until turning has mostly stopped and we assign a small frame base delay around 2 frames before confirming it is ready to shoot. And we got controlled turn rate based, meaning we turn faster if it's far away and turn slower if it's closer. And we also choose the shortest direction to turn from, so whether it's clockwise or counterclockwise. And then we also got recoding when an asteroid will be shot. Basically, predict future hit time and track which asteroids are being shot so that for next time you don't have to shoot the same one because we know it's already been shot at. Wait, so what about mines? Well, mines are a reactive defensive move triggered by an imminent threat, right? To put it simply, the ship's immobile, it can't move anything. So if an asteroid is going to hit it, it's going to hit it. And so we go kamikaze on it. We're going to go out with a bang. There's a few conditions we look out for, but the idea is if an asteroid is going to hit it, we're going to drop a bomb right before it hits, and then the mine will destroy the asteroid. But since we got hit, we are also in a state of invulnerability, meaning we don't take any damage. So the asteroid, by the time the mine finishes exploding, will revive and will be safe and sound, and the whole area is cleared. So it's a nice little strategy because we can use the mine without actually losing additional lives, aka we only use it when we need to. And so there's some optimizations we've done so far. The biggest one is the JSON lookup table, where the fuzzy logic technically returns 36,000 values, and looking through them every single time is a pain in the ass. So we pre-compute the values, put it in a JSON table, and so that gives us a lookup time of 0, big O of 1, big O of 1, and it helps us avoid computing calculations and a bunch of other things. We also got the collision prediction function, which also has a complexity of big O of 1. And then we got priority retention. It reduces the amount of recalculations needed for asteroids, just because we are reusing previous ones. And also cleaning up short asteroid lists. It prevents memory bloats and confusion and only tracks relevant asteroids that are alive. And that is my agent. Thank you very much.
Okay, thanks Akila for presenting your solution. So that is the end of the student presentations since Team Temp Variable isn't here today and didn't provide a recording. So shortly we will move on to the big show, the playoff itself. I'm going to stop the recording of this part of the competition, and then we will resume. I'll still be in the Teams meeting. I'll leave the Teams meeting open, but I'll start the live stream of the playoff on YouTube. Does everybody have the YouTube link? I'll put it in the chat as well. Okay. I'm gonna go ahead and stop the recording again. I'm staying on Teams and everything, and then we'll take a quick, let's say, 4-minute break. So we'll be back at 12:02 p.m. Eastern, and then we'll go ahead and start the playoff.